understanding the respiratory system, let's do a brief overview just to give you an idea of how oxygen and carbon dioxide and what's the whole point of all of this? How does it work? Okay. We have the upper tract, we have the lower tract. We're going to talk about the lungs, we're going to talk about the throat. Let's get right into it. So let me share my screen. There we go. So you guys can see it a bit bigger. So here's just a fun, cool little video here. So a lot's going on, right? How we breathe is so important. How does that work exactly? Why do some people have asthma? Why do some people have trouble breathing? How does it work when we're eating and drinking food? Where does that go? How does the body know what to do so we're still breathing? Why are we breathing voluntarily and then sometimes it's involuntary where we don't know we're doing it, but our body just knows to do it? So the primary function is gas exchange, which involves taking the oxygen from the air and then removing carbon dioxide from the blood. So blood, think oxygen, okay? Hemoglobin carries that oxygen. So that's very, very important. This system it plays a critical role in maintaining acid and base balance and filtering inhaled particles to ensure air quality. So if the carbon dioxide is too high and the oxygen is too low, so more of an acidic, then the body needs to balance that out because we don't like that. Vice versa, if the oxygen is too high but the carbon dioxide is too low, that doesn't work either. So the body needs to maintain homeostasis to balance everything out. But also, the the respiratory system is responsible for producing vocal sounds, which is essential for communication and expression. So the lungs, we have the bronchi, we have the bronchioles. What's so special about them and what role do they play? When we're breathing in, our lungs, our diaphragm, act a certain way. When we're breathing out to exhale to get the carbon dioxide out, our lungs and diaphragm are acting another way. So we will talk about that in a little bit. So the upper tract includes the nasal cavity, the pharynx, and the larynx. This is involved in filtering, warming, and humidifying the air before it enters the lungs. So the lungs can accept it, basically. This is essential. If this isn't happening, either the nasal cavity, the pharynx, or the larynx isn't working properly, that's not good. But then you have the lower tract, which consists of the trachea, the bronchi, the bronchioles, and the lungs. So I tell my students, think of the lower tract as the lungs and all that the lungs has. The upper tract is basically like everything else. The nose, which is involved in smelling, breathing the air in. The mouth, which takes air in as well. So the mouth, throat areas. The trachea is the main airway leading to the lungs. The bronchi and the bronchioles conduct air to the alveoli for gas exchange. So the nasal cavity, larynx, pharynx, and then additional structures. So the nasal cavity is lined with mucous membranes, which is like hair-like structures called the cilia. Very important. The cilia is what filters out those particles. So when it reaches the lungs know what to do with it. But then you have the larynx, which is the voice box, but don't confuse the larynx, which is the voice box. Don't confuse that with the pharynx, which is a tube that helps to serve as a passageway for both air and food. The pharynx is even further divided into the nasopharynx, the oropharynx, and the laryngeal pharynx. These play a role in swallowing and passage of air. But the larynx, which is the voice box, is located at the top of the trachea, contains the vocal cords. This produces sound. It does protect the airway during swallowing, and it just helps to regulate the flow overall, the flow of air to the lungs overall. But then there's also additional structures such as the epiglottis, the uvula, and the tonsils. So the epiglottis is very important. This helps to prevent food from entering the airway. The uvula helps with speech and swallowing, and the tonsils play a role in the immune defense. So if any of these are injured or trauma, not good. If the tonsils are too big, you might think, yay, that sounds awesome. They're more protected against diseases. But no, if the tonsils are too big, it's impeding the airway. So now, sure, it's protecting against diseases, but the patient can't breathe or having trouble breathing whenever they get sick. The tonsils can become even more inflamed, which makes it harder to breathe. When the tonsils are more inflamed, it's harder to heal them, and then it takes longer. Then you have other problems because the patient's not able to get air into their lungs properly. So it's a big can of worms there. But if any of these things aren't functioning properly, we have problems. So talking a little bit now about the trachea, the bronchi and the bronchioles, the lung, the gas exchange. So the trachea is that tube that extends from the larynx to the bronchi. It's reinforced with those C-shaped rings that are made of cartilage basically. So when we're breathing in and then breathing out, they need to expand, and they're made of cartilage so that they can do that. But then you have the bronchi and the bronchioles that it like further divides into, which brings the air deeper into the lungs. The lungs itself are our spongy organs, of course, and that's where gas exchange occurs. The alveoli in the lungs are tiny air sacs serving as the primary site for gas exchange. So when they ask you what gas exchange is, that occurs in the lungs. Oxygen diffuses into capillaries, binding to the hemoglobin, while carbon dioxide diffuses out to be exhaled. So we talked about our nasal cavity. We talked about the pharynx, which is then further subdivided. But then you have those further subdivisions. The 1, 2, 3, right? The nasopharynx, the oropharynx, and the laryngeal pharynx. So the nasopharynx is the uppermost part of the pharynx behind the nasal cavity above the soft palate. This serves as the air passage during breathing. Very important. The key structures here include the pharyngeal tonsils, which are the adenoids, and the openings of tubes, okay? These estrogen, I'm probably not saying that properly, tubes that are important because this all plays a part with those tonsils. If the adenoids tonsils become enlarged, as I said, this can obstruct the airflow. But then you have the oropharynx, which is located behind the oral cavity, extending from the soft palate above to the level of the hyoid bone. So this is your anatomy for you here. This serves as a passage for both air and food. This plays a critical role in swallowing. So this helps to create that food into a ball that's easy to move down the throat, basically, into the esophagus. Okay. The important structures here are the palatine tonsils. So remember the last one, the nasopharynx, we talked about the adenoids. Those are the pharyngeal tonsils, but there's different ones. There's the palatine tonsils, which are off to the sides more. So they're located on the lateral walls, and then the lingual tonsils, which are different ones again, are located at the base of the tongue. But remember, we talked about the uvula. So this and the soft palate, they're very close to one another. You have the hard palate, the soft palate lower down, and then you have the uvula at the back of the throat. This helps to close off the nasopharynx, which we talked about in this slide, while you're swallowing to prevent food from entering the nasal cavity because we don't want it to go up. We don't want it to go down into the lungs. So this all works together. And then the laryngeal pharynx, which is also known as the hypopharynx, is the lowest part of the pharynx, extending from the hyoid bone to the entrance of the esophagus and the larynx. This is a passageway also for food and air. It plays a critical role in directing food and liquid into the esophagus while keeping the airway open for breathing because we need to breathe at the same time. This here is bordered by the epiglottis, which is that flap-like structure which we talked about that closes over the throat during swallowing to prevent aspiration of food or liquid into the lungs. So you have this esophagus, which is where the food and the liquid go down. So it doesn't go into the lungs. The epiglottis is that flap that closes over the throat during swallowing to prevent aspiration of food or liquid into the lungs. Okay, so there's lots happening here. So again, as a recap, all of these things play a role. The larynx, the voice box is more for producing sound. It's critical in speech production and preventing the food or liquids from entering the airway during swallowing. The epiglottis is there, or sorry, the epiglottis is the flap that goes over so that the esophagus can accept the food and everything, but it doesn't go into the lungs. So again, breathing in and out, breathing is important, obviously, because it moves the air in and out of the lungs. You have the diaphragm that helps assist with that. When we inhale, that is called inspiration. When we exhale, that is called expiration. So inhaling, the diaphragm contracts and moves downward, while the intercostal muscles, remember there's cartilage there, it is going to contract to lift the rib cage. But when we exhale, because we inhale and then we exhale, the diaphragm and intercostal muscles relax now. So it's different. And when we exhale, this can either be passive or active. So we're not always thinking about it, but sometimes we're consciously doing it, like if we're meditating or if we're exercising. Last but not least here, oxygen and carbon dioxide transport. So oxygen is important in the blood, primarily bound to hemoglobin, forming oxyhemoglobin. So a small amount of oxygen is also dissolved in the plasma. Hemoglobin plays a crucial role in carrying oxygen from the lungs to the body's tissues. So you need the hemoglobin, right? Carbon dioxide is transported in the blood in three forms. It's dissolved in plasma as bicarbonate ions and bond to hemoglobin as carbaminohemoglobin. The transport of carbon dioxide is essential for maintaining the body's acid-base balance and regulating respiration. The binding of carbon dioxide to hemoglobin facilitates its transport to the lungs for exhalation. So how did you guys do with that? Was that exciting? Do you understand things now a little bit better? Let me know if you guys have any questions. I am always here to help. Let me know if you need anything, comment below. I'm not an anatomy teacher. I'm a dental hygienist that teaches anatomy to my students, so I could have pronounced things not correct. So I'm sorry. I hope you guys had a good laugh. But comment if you guys need anything. Thank you for watching, and I'll see you in the next one.